All right, if you took my Introduction to Sprite Kit course, you are probably chomping at the bit to see some of the physics things that you can do in Sprite Kit. So we'll lead off with basically just creating our world and running through a few quick little tests that you can do with physics. So let's go, and inside of our init statement, let's get rid of this for right now. In fact, what I'll do is I'll just leave that commented out because we can go and steal some of that label code for later. But let's do this. Let's write in here self set up scene, and of course that is a method name, and we don't actually have a corresponding method there. So let's go ahead and write one, void set up scene, and when we do that, that little red dot should go away. And let's put a little note here. Take care of setting up the world, and later on we'll and bring in the property list. I'll leave that alone for right now, just so we get to play with some fun stuff, and you'll appreciate that certainly if you already know how to work with property lists. All right, so I should say at the top of this file, what I'm going to do is declare some things that we're going to want to access throughout kind of the entire run of this program here in various methods. And if I were to just write in here, for example, sknode, just kind of your basic building block of anything in Sprite Kit, my world, I'm limiting the scope of this, okay? After or whenever after this this method was done running, my world is simply kind of not accessible here, all right? Because I just declared this again locally, just kind of inside of this one particular method. Now, if I had declared it outside of that in a place up here, I'd be able to access my world throughout any of these possible methods that I'm going to write. So that is why we're going to do this, and here's how we do it. We're going to put up here at interface, and then we can spit back CS level, so that's just our class name again, and you put inside, or actually just write those little two brackets right there, and then we don't need to put that superclass. Alright, so this is where we will declare things, and if you guys are kind of used to doing it another way, you can do it. You can still do it that other way. You can put things back over here as well, but I do see the benefit of doing it over here in our implementation file, and I think it's just that it's a little quicker, really. I mean, you can just run up here to the top of your file and declare things like that sknode there. Instead of having to go run back to your header file. There will be some things that we declare in our header file, but those will be properties down the road that we're gonna, and actually I'm not even, well, they'll be in the character file. They won't even be our level 1, I don't think. So anyway, yes, we have our sknode, our Sprite Kit node. Yeah, a node sounds like a silly word. It's just again, it's our kind of our most basic object, and we can put other objects inside of here, and that's the whole point of creating a world here. So it's just going to be something that we put other things inside of, and one of the reasons that we're doing that is so we can have our character yes, our world basically be centered on whoever is the lead character there. So now let's cut back down here to setup scene, and we are going to put in my world equals sknode. This is just going to initialize it, and then we're going to write in here self add child my world. So now we've added that child to the world, and I left off one line up here. I'm just going to make the anchor point of our entire class be cg point make, and this is going to be 0.5, 0.5, and our ranges here are it'd be 0, 0 to 1, 1, I believe. I have to recheck that, but I believe 0, 0 is in the bottom left, and I believe by default that's where our scene, and keep in mind that self here refers to our SK scene. Okay, so when I write self, that's referring to this class, which is a scene. I believe the default center point for those is in the bottom left, which is at 0, 0, whereas 1, 1 would be up in the top right. So basically I'm just making our center point be right there, kind of dead center in the middle. And again, this goes back to kind of keeping everything centered. So we should now be basically creating our world in the center of the screen. Of course, we don't really have any visual representation of any of this right now, so that'll be one of the next things we do, which will be to go ahead and add in at least one sprite, and let's do that. So we're going to come down here and write SK sprite node. We'll call this one map equals SK sprite node with image named, and later on we're going to replace this with the name of the file as defined by the property list. But while we're just getting started, let's not worry about that. We do need to put in here level map 1, and of course that is that same name of the file that we have in the property list right now. It's also the name of this right here, and you don't have to put that .png name after it. And if there is a alternate HT1, it'll automatically detect that and use that one. So you don't have to put @2x behind that either. Now I'm going to put map.position equals cg point make, and we can just put in here 0, 0. Now keep in mind that because we set our anchor point to being at 0.5, 0.5, that's basically setting our 0, 0 point to the middle. And well, we're going to put this map into my world anyway, which is going to have its 0, 0 point centered regardless. So next line will be to actually just add that child. So we're going to put in here my world, add child, map, and if we give this give this a little test run here, we should just see, well, a grid, because remember this our map is a pretty big image anyway. There it is. So yeah, you don't really get to see much. If we were to come in here and write map dot x scale equals 0.5 and map dot y scale equals 0.5. Now what we should be seeing when we run this is the entire map, and there it is, and it's nicely centered up inside of there. You know, notice that even though we only have one node inside of here now, there's this is set to, I mean, this is running at 30 frames per second. So when we do actually have characters running around, things like that, and you see that the frame rate is only at 30 frames per second, don't think that that's because of those characters running around. It's just that the simulator is generally going to be a lot slower than your actual devices. All right, so we've got this centered up. Again, keep in mind our middle point, or our 0, 0 point, is squarely in the middle of the stage there, and we can go to wipe out our X and Y scaling. Of course, by default they're at 1 and 1, which is at 100%. And now one of the things that we can do is let's go ahead and set up our physics world, and we can do that right here. Let's put a little note. Set up physics. All right, self dot physics world dot gravity. It's going to be CG vector make, and you guys might have seen in the beta versions of Xcode 5, you actually just put a CG point here, and they changed it at the very end to CG vector make, but it's very similar. It's the first number here is going to be controlling the basically the horizontal forces, and the second one is going to be the vertical forces. So if we were to just put in here 0, 0, there's no forces applied anywhere, right? Now if we had this set to 1, then it would pull our objects to the right. If we had this set to -1, and pull them to the left. And don't think that that's your range, though. You could have this quite higher. And same thing over here. So if you were to set this to like -0.9, that would pull everybody down to the bottom of the stage. All right, I'm going to go ahead and put in here self.physicsworld.contactDelegate is going to equal self, and that really just means that. And here you get that nice little warning. It says assigning to ID SK physics contact delegate from incompatible to whatever. It's just mad at me right now because I haven't gone over here to my header file and said that this class is going to be the physics contact delegate, and that should solve that little problem right there. Let's cut back over here to this and see if that goes away, and sure enough it did. Basically, I'm just saying that, you know what, I'm going to be responsible, this class is going to be responsible for handling what to do with contacts. Okay, so when one thing bumps up against another, and you know, I think we can still get away with publishing this at this point, even without the actual method that handles that contact delegation or the contacting. And I'm not seeing any sort of warnings or errors yet, so I'll assume we're still good there. But later on, we're going to put in a method here that's very soon, actually, we'll put in here a method that deals with that. All right, now, you know what, let's go ahead and take I don't know, I guess we'll just leave all the physics under kind of one heading here, but now we'll skip back to playing around with our world. So my world, we're going to say physics body, and this is going to equal SK physics body with edge loop from rect. And for now, let's just make this the rectangle end up being the map.frame. And you'll see as I type in just the FR here, just the F, it'll autofill in for me frame, and that's really not the point. What I want to show you is that it's asking me here body with edge loop from rect, and then I missed it, and then showing me that the frame property is a CG rect. So that's always a good sign that you're something's asking for a rectangle, that you give them that particular property. So versus the frame has some sub properties here. So you know, if you try to put in frame.size, that's not correct, because you see that's a CG size right there. So it's that frame that it wants, and that will basically just make the body of this, the boundaries of it, be that same rectangle is defined by, you know, the size of our image, right? Later on, what we'll do is actually kind of shift the potential border by making it it could be a fraction of that particular size of the background image. In the example you guys saw in the introduction, it was 90% of the actual image size. All right, so my world dot physics body dot category bitmask. Okay, let's read a little bit over here. It says a mask that defines which categories this physics body belongs to. Every physics body in a scene can be assigned to up to 32 different categories, each corresponding to a bit in the bit mask. It's getting a little technical now. The default value is 0, and then X, F, all bits. All right. You can put in here, you can define these in bits, or as I found, you can just put in here numbers. Simple integers like this. So you can just say the category here is 1, category here is 2. What makes a little bit more sense is to go and define something in our constants file. So let's have let's define a wall category, right? And if you guys remember from the last video, we set up a constants file over here. So let's continue this, and we'll have a static constant int. That'll be our wall category, and let's just make it equal to 4. I'm saying 4 because that's what it equaled in my original test project. And I'm going to throw in here another one, which will be our player category. And if you're wondering why we are setting up these categories for things, it's really I don't know why I'm getting a warning here. Oh, probably because, hold on, I'll continue that thought in a second. Let me go over here and actually import in the constants.h file. And as soon as I do that, I should see that disappear. All right, so, and this will turn green as well, so it knows what I'm referring to here. In our method that we write later on to detect when things have contacted each other, basically what happens is you have two bodies, right? If there is one thing is contacting another, you have the first object or node, and then you have the second object or node. So what we're going to want to find out is, all right, well, what was the category of that first node? What was the category of that second node? And we're basically just kind of running if statements in there that say, all right, well, if you were a wall and you hit a player, then maybe you're going to damage that player. Or if you were a player that hit another player, we don't care about that, so ignore it, okay? And you can set up these situations where you don't care, or you do care, right? And that's nice because then, you know, if you set it so that a player can just run up against a brush or something like that and never have any sort of collision or things like that, you know, it obviously saves on the program kind of having to process, well, what do you do in this case? Nothing. Great. Let's move on. Okay, so speaking of moving on, let's go back over here to our level and see what other things we need to initially set up here. Obviously, the fun thing to test will be actually getting some sort of character in here that can react to the gravity that we set up. Even though gravity obviously doesn't play much into my example project, it's a fun thing to kind of play around with early on. All right, well, yeah, I think we're on to that stage. So let's come up here and. I mean, we could write this at the end of this statement. I'm going to write it just over here, and I'm going to write self perform selector, and at selector, I'm going to say set up characters, and I don't need an object. With object will be nil. What I really want from this is just to delay it a little bit. I'm going to put in here a let's make it a 4-second delay. And the reason I'm doing that is because later on, of course, we're going to put some text in here that just basically gives some instructions, swipe up or down, things like that. And 4 seconds is about right. So need to put in here set up characters, and we should stop getting warnings. We can at this point put in an nslog statement that just kind of tells us that this is actually running. Set up characters, and let's make sure that we're seeing that. Just to prove that I can write in here a method with a 4-second delay. All right, so it's running it, and sure enough, well, I guess that was 4 seconds, set up characters. So let's take a little break, and when we come back, we'll actually set up those characters.